Sciacademy presents Audiobook of Chemistry for Class 11 entitled Chemistry Part 2, written by NCERT. This is page number 406, Chapter 14 or Unit 14, Environmental Chemistry. The objectives of this chapter. After studying this unit, you will be able to understand the meaning of environmental chemistry, define atmospheric pollution, list reasons for global warming, greenhouse effect, and acid rain, identify causes for ozone layer depletion and its effects, give reasons for water pollution, and know about international standards for drinking water, describe causes of soil pollution, suggest and adopt strategies for control of environmental pollution, appreciate the importance of green chemistry in day to day life. The world has achieved brilliance without wisdom, power without conscience. Ours is a world of nuclear giants and ethical infants. You have already studied about environment in your earlier classes. Environmental studies deal with the sum of all social, economical, biological, physical, and chemical interactions with our surroundings. In this unit, the focus will be on environmental chemistry. Environmental chemistry deals with the study of the origin, transport, reactions, effects, and effects of chemical species in the environment. Let us discuss some important aspects of environmental chemistry. 14.1 Environmental pollution. Environmental pollution is the effect of undesirable changes in our surroundings that have harmful effects on plants, animals, and human beings. A substance which causes pollution is known as pollutant. Pollutants can be solid, liquid, or gaseous substances present in greater concentration than in natural abundance and are produced due to human activities or due to natural happenings. Do you know an average human being requires nearly 12 to 15 times more air than the food? So, even small amounts of pollutants in the air become significant compared to similar levels present in the food. Pollutants can be degradable, like discarded vegetables, which rapidly break down by natural processes. On the other hand, pollutants, which are slowly degradable, remain in the environment in an unchanged form for many decades. For example, substances such as dichloro, diphenyl, trichloroethane, ncert, DDT, plastic materials, heavy metals, many chemicals, nuclear wastes, etc., once released into the environment are difficult to remove. These pollutants can be degraded by natural processes and are harmful to living organisms. In the process of environmental pollution, pollutants originate from a source and get transported by air or water or are dumped into the soil by human beings. 14.2 Atmospheric pollution. The atmosphere that surrounds the Earth is not of the same thickness at all heights. There are concentric layers of air or regions, and each layer has different density. The lowest region of atmosphere in which the human beings, along with other organisms, live is called troposphere. It extends up to the height of about 10 km from the sea level. Above the troposphere, between 10 and 50 km above sea level, lies stratosphere. Troposphere is a turbulent, dusty zone containing air, much water vapor, and clouds. This is the region of strong air movement and cloud formation. The stratosphere, on the other hand, contains dinitrogen, dioxygen, ozone, and little water vapor. Atmospheric pollution is generally studied as tropospheric and stratospheric pollution. The presence of ozone in the stratosphere prevents about 99.5% of the sun's harmful ultraviolet UV radiations from reaching the Earth's surface and thereby protecting humans and other animals from its effect. 14.2.1 Tropospheric pollution. The tropospheric pollution occurs due to the presence of undesirable solid or gaseous particles in the air. The following are the major gaseous and particulate pollutants present in the troposphere. Gaseous air pollutants. These are oxides of sulfur, nitrogen, and carbon, hydrogen sulfide, hydrocarbons, ozone, and other oxidants. Number two, particulate pollutants. These are dust, mist, fumes, smoke, etc. Point number one, gaseous air pollutants. A. Oxides of sulfur. Oxides of sulfur are produced when sulfur containing fossil fuel is burned. The most common species, sulfur dioxide, is a gas that is poisonous to both animals and plants. It has been reported that even a low concentration of sulfur dioxide causes respiratory diseases, for example, asthma, bronchitis, emphysema in human beings. Sulfur dioxide causes irritation to the eyes, resulting in tears and redness. High concentration of sulfur dioxide leads to the stiffness of flower buds, which eventually fall off from plants. Uncatalyzed oxidation of sulfur dioxide is slow. However, the presence of particulate matter in polluted air catalyzes the oxidation of sulfur dioxide to sulfur trioxide. 2SO2 gaseous form plus oxygen O2 gaseous leads to 2SO3 in gaseous form. The reaction can also be promoted by ozone and hydrogen peroxide, such as SO2 in gas form plus O3 in gas leads to SO3 in gas plus O2 in gas. SO2 in gas plus H2O2 in liquid form leads to H2SO4 in aqueous form. B. Oxides of nitrogen. Dinitrogen and dioxygen are the main constituents of air. These gases do not react with each other at a normal temperature. At high altitudes, when lightning strikes, they combine to form oxides of nitrogen. NO2 is oxidized to nitrate ion NO3 minus, which is washed into soil. where it serves as a fertilizer. In an automobile engine, at high temperature, when fossil fuel is burned, dinitrogen and dioxygen combine to yield significant quantities of nitric oxide (NO) and nitrogen dioxide (NO2) as given below. N2 in gas form plus O2 in gas leads to, at higher temperature 1483 Kelvin, twice nitric oxide in gaseous form. Nitric oxide reacts instantly with oxygen to give nitrogen dioxide. 2NO in gas form plus O2 in gas leads to 2NO2 in gas. Rate of production of NO2 is faster when nitric oxide reacts with ozone in the stratosphere. NO gas plus O3 in gas leads to NO2 gas plus O2 gas. The irritant red haze in the traffic and congested places is due to the oxides of nitrogen. Higher concentrations of NO2 damage the leaves of plants and retard the rate of photosynthesis. Nitrogen dioxide is a lung irritant that can lead to an acute respiratory disease in children. It is toxic to living tissues. Also, nitrogen dioxide is harmful to various textile fibers and metals. C. Hydrocarbons. Hydrocarbons are composed of hydrogen and carbon only and are formed by incomplete combustion of fuel used in automobiles. Hydrocarbons are carcinogenic, that is, they cause cancer. They harm plants by causing aging, breakdown of tissues, and shedding of leaves, flowers, and twigs. D. Oxides of carbon. Number 1. Carbon monoxide. Carbon monoxide (CO) is one of the most serious air pollutants. It is a colorless and odorless gas, highly poisonous to living beings because of its ability to block the delivery of oxygen to the organs and tissues. It is produced as a result of incomplete combustion of carbon. Carbon monoxide is mainly released into the air by automobile exhaust. Other sources which produce carbon monoxide involve incomplete combustion of coal, firewood, petrol, etc. The number of vehicles has been increasing over the years all over the world. Many vehicles are poorly maintained and several have inadequate pollution control equipments resulting in the release of greater amount of carbon monoxide and other polluting gases. Do you know why carbon monoxide is poisonous? It binds to hemoglobin to form carboxyhemoglobin, which is about 300 times more stable than the oxygen hemoglobin complex. In blood, when the concentration of carboxyhemoglobin reaches about 3 to 4%, the oxygen carrying capacity of blood is greatly reduced. This oxygen deficiency results into headache, weak, weak eyesight, nervousness, and cardiovascular disorder. This is the reason why people are advised not to smoke. In pregnant women who have the habit of smoking, the increased CO level in blood may induce premature birth, spontaneous abortions, and deformed babies. Point 2. Carbon dioxide. Carbon dioxide (CO2) is released into the atmosphere by respiration, burning of fossil fuels for energy, and by decomposition of limestone during the manufacture of cement. It is also emitted during volcanic eruptions. Carbon dioxide gas is confined to troposphere only. Normally, it forms about 0.03% by volume of the atmosphere with The increased use of fossil fuels, a large amount of carbon dioxide gets released into the atmosphere. Excess of CO2 in the air is removed by green plants, and this maintains an appropriate level of CO2 in the atmosphere. Green plants require CO2 for photosynthesis and they in turn emit oxygen, thus maintaining the delicate balance. As you know, deforestation and burning of fossil fuel increases the CO2 level and disturbs the balance in the atmosphere. The increased amount of carbon dioxide CO2 in the air is mainly responsible for global warming. Global warming and greenhouse effect. About 75% of the solar energy reaching the earth is absorbed by the earth's surface, which increases its temperature. The rest of the heat radiates back to the atmosphere. Some of the heat is trapped by gases such as carbon dioxide, methane, ozone, chlorofluorocarbon compounds, CFCs, and water vapor in the atmosphere. Thus, they aid to the heating of the atmosphere. This causes global warming. We all know that in cold places, flowers, vegetables, and fruits are grown in glass covered areas called greenhouse. Do you know that we humans also live in a greenhouse? Of course, we are not surrounded by glass, but a blanket of air called the atmosphere, which has kept the temperature on Earth constant for centuries. But it is now undergoing change, though slowly, just as the glass in greenhouse holds the sun's warmth inside, the atmosphere traps the sun's heat near the Earth's surface and keeps it warm. This is called the natural greenhouse effect because it maintains the temperature and makes the Earth perfect for life. In a greenhouse, solar radiations pass through the transparent glass and heat up the soil and the plants. The warm soil and plants emit infrared radiations. Since the glass is opaque to infrared radiation, that is thermal region, it partly reflects and partly absorbs these radiations. This mechanism keeps the energy of the sun trapped in the greenhouse. Similarly, carbon dioxide molecules also trap heat as they are transparent to sunlight but not to the heat radiation that falls in the infrared region. If the amount of carbon dioxide crosses the delicate proportion of 0.03%, the natural greenhouse balance may get disturbed. Carbon dioxide is the major contributor to global warming. Besides carbon dioxide, other greenhouse gases are methane, water vapor, nitrous oxide, CFCs, and ozone. Methane is produced naturally when vegetation is burnt, digested, or rotted in the absence of oxygen. Large amounts of methane are released in paddy fields, coal mines, from rotting garbage dumped and by fossil fuels. Chlorofluorocarbons (CFCs) are man-made industrial chemical used in air conditioning, etc. CFCs are also damaging the ozone layer. Section 14.2.2. Nitrous oxide occurs naturally in the environment. In recent years, their quantities have increased significantly due to the use of chemical fertilizers and the burning of fossil fuels. If these trends continue, the average global temperature will increase to a level which may lead to melting of polar ice caps and flooding of low-lying areas all over the earth. Increase in the global temperature increases the incidence of infectious diseases like dengue, malaria, yellow fever, sleeping sickness, etc. Think it over. What can we do to reduce the temperature of global warming. If burning of fossil fuels, cutting down forests, and trees add to greenhouse gases in the atmosphere, we must find ways to use these just efficiently and judicially. One of the simple things which we can do to reduce global warming is to minimize the use of automobiles. Depending upon the situation, one can use bicycle, public transport system, or go for carpooling. We should plant more trees to increase the green cover, avoid burning of dry leaves, wood, etc. It is illegal to smoke in public places and workplaces because it is harmful not only for the one who is smoking but also for others, and therefore we should avoid it. Many people don't understand the greenhouse effect and the global warming. We can help them by sharing the information that we have. Acid rain. We are aware that normally rainwater has a pH value of 5.6 due to the presence of hydronium ions formed by the reaction of rainwater with carbon dioxide present in the atmosphere. H2O in liquid plus CO2 in gas leads to H2CO3 aqueous. H2CO3 in turn produces H plus ion plus HCO3 minus ion aqueous. When the pH of the rainwater drops below the value of 5.6, it is called acid rain. Acid rain refers to the ways in which acid from the atmosphere is deposited on the Earth's surface. Oxides of nitrogen and sulfur, which are acidic in nature, can be blown by wind along with solid particles in the atmosphere and finally settle down either on the ground as dry deposition or in water, fog, and snow as wet deposition. Figure 14.1. Acid rain is a byproduct of a variety of human activities that emit the oxides of sulfur and nitrogen in the atmosphere. As mentioned earlier, burning of fossil fuels, which contain sulfur and nitrogenous matter such as coal, oil in power stations and furnaces, or petrol and diesel in motor engines, produce sulfur dioxide and nitrogen oxides. SO2 and NO2 after oxidation and reaction with water are major contributors to acid rain. Because polluted air usually contains particulate matter that catalyze the oxidation as follow: 2SO2 gas plus O2 gas plus 2H2O liquid gives 2H2SO4 aqueous. 4NO2 gas plus O2 gas plus 2H2O liquid gives 4HNO3 aqueous. Ammonium salts are also formed and can be seen as an atmospheric haze, that is, aerosol of fine particles. Aerosol particles of oxides or ammonium salts in raindrops result in wet deposition. SO2 is also absorbed directly on both solid and liquid ground surfaces and is thus deposited by as dry deposition. Acid rain is harmful for agriculture, trees, and plants as it dissolves and washes away nutrients needed for their growth. It causes respiratory ailments in human beings and animals. When acid rain falls and flow as groundwater to reach rivers, lakes, etc., it affects plants and animal life in aquatic ecosystem. It corrodes water pipes, resulting in the leaching of heavy metals such as iron, lead, and copper into the drinking water. Acid rain damages buildings and other structures made of stone or metal. The Taj Mahal in India has been affected by acid rain. Taj Mahal and acid rain. Air around the city of Agra, where the Taj Mahal is located, contains fairly high level of sulfur and nitrogen oxides. It is mainly due to a large number of industries and power plants around the area. Use of poor quality of coal, kerosene, and firewood as fuel for domestic purposes add up to this problem. The resulting acid rain reacts with marble calcium carbonate of Taj Mahal, causing damage to this wonderful monument that has attracted people from around the world. As a result, the monument is being slowly disfigured and the marble is getting discolored and lusterless. The Government of India announced an action plan in early 1995 to prevent the disfiguring of this historical monument. Mathura refinery has already taken suitable measures to check the emission of toxic gases. This plan aims at clearing the air in the Taj Trapezium, that is an area that includes the towns of Agra, Firozabad, Mathura, and Bharatpur. Under this plan, more than 22,000 polluting industries lying inside the trapezium would switch over to the use of natural gas or liquefied petroleum gas (LPG) instead of coal or oil. A new natural gas pipeline would bring more than half a million cubic meters of natural gas a day to this area. People living in the city will also be encouraged to use liquefied petroleum gas in place of coal, kerosene, or firewood. Vehicles plying on highways in the vicinity of Taj would be encouraged to use low sulfur content diesel. 2. Particulate pollutants. Pollutants are the minute solid particles or liquid droplets in air. These are present in vehicle emissions, in smoke particles from fires, dust particles, and ash from industries. Particulates in the atmosphere may be viable or non-viable. The viable particulates, for example, bacteria, fungi, molds, algae, etc., are minute living organisms that are dispersed in the atmosphere. Human beings are allergic to some of the fungi found in air. They can also cause plant diseases, whereas non viable particulates may be classified according to their nature and size as follows. A smoke particulates consists of a solid or mixture of solid and liquid particles formed during combustion of organic matter. Examples are cigarette smoke, smoke from burning of fossil fuel, garbage and dry leaves, oil smoke, etc. B. Dust is composed of fine solid particles having sizes over 1 micrometer in diameter, produced during crushing, grinding, and attribution of solid materials. Sand from sand blasting, dust from woodworks, pulverized coal, cement, and fly ash from factories, dust storms, etc., are some typical examples of this type of particulate emission. Mists are produced by particles of spray liquids and by condensation of vapors in air. For example, sulfuric acid mist and herbicides and insecticides that miss their targets and travel through air and form mists. D. Fumes are generally obtained by the condensation of vapors during sublimation, distillation, boiling, and several other chemical reactions. Generally, organic solvents, metals, and metallic oxides form fume particles. The effect of particulate pollutants are largely dependent on the particle size. Airborne particles such as dust, fumes, mist, etc. are dangerous for human health. Particulate pollutants bigger than 5 microns are likely to lodge in the nasal passage, whereas particles of about 10 microns enter into lungs easily. Lead used to be a major air pollutant emitted by vehicles. Leaded petrol used to be the primary source of airborne lead emission in Indian cities. This problem has now been overcome by using unleaded petrol in most of the cities in India. Lead interferes with the development and maturation of red blood cells. Smog. The word smog is derived from smoke and fog. This is the most common example of air pollution that occurs in many cities throughout the world. There are two types of smog. A. Classical smog occurs in cool, humid climate. It is a mixture of smoke, fog, and sulfur dioxide. Chemically, it is a reducing mixture and so it is called as reducing smog. B. Photochemical smog occurs in warm, dry, and sunny climate. The main components of the photochemical smog results from the action of sunlight on unsaturated hydrocarbons and nitrogen oxides produced by automobiles and factories. Photochemical smoke has high concentration of oxidizing agents and is therefore called as oxidizing smoke. Formation of photochemical smoke. When fossil fuels are burnt, a variety of pollutants are emitted into the Earth's troposphere. Two of the pollutants that are emitted are hydrocarbons and nitric oxides. When these pollutants build up to sufficiently high levels, a chain reaction occurs from their interaction with the sunlight, in which nitric oxide is converted into nitrogen dioxide. This nitrogen dioxide, NO2, in turn absorbs energy from sunlight and breaks up into nitric oxide and free oxygen atoms. Figure 14.2. NO2 gas tends to under the sunlight H nu energy NO, that is nitric oxide plus oxygen gaseous forms. Oxygen atoms are very reactive and combine with O2 in air to produce ozone. The ozone formed in the above reaction number 2 reacts rapidly with the nitric oxide gaseous form formed in the reaction 1 to regenerate NO2. NO2 is a brown gas and its sufficiently high level can contribute to haze. Nitric oxide ozone react together to give nitrogen dioxide gas plus O2 gas. Ozone is a toxic gas and both NO2 and O3 are strong oxidizing agents and can react with the unburnt hydrocarbons in the polluted air to produce chemicals such as formaldehyde, acrolein, and peroxyacetyl nitrate (PAN). Effects of photochemical smog. The common components of photochemical smog are ozone, nitric oxide, acrolein, formaldehyde, and peroxyacetyl nitrate, that is PAN. Photochemical smoke causes serious health problems. Both ozone and PAN act as powerful eye irritants. Ozone and nitric oxide irritate the nose and the throat, and their high concentration causes headache, chest pain, dryness of the throat, cough, and difficulty in breathing. Photochemical smoke leads to cracking of rubber and extensive damage to plant life. It also causes corrosion of metals, stones, building materials, rubber, and painted surfaces. Figure 14.2 Photochemical smoke occurs where sunlight acts on vehicle pollutants. How can photochemical smoke be controlled? Many techniques are used to control or reduce the formation of photochemical smoke. If we control the primary precursors of the photochemical smoke, such as nitrogen dioxide and hydrocarbons, the secondary precursors, such as ozone and PAN, the photochemical smoke will automatically be reduced. Usually, catalytic converters are used in the automobiles, which prevents the release of nitrogen oxide and hydrocarbons to the atmosphere. Certain plants, for example, Pinus, Juniperus, Curicus, Pyrus, and Vitis, can metabolize nitrogen oxide, and therefore their plantation could help in this matter. 14.2.2 Stratospheric pollution, formation and breakdown of ozone. The upper stratosphere consists of considerable amount of ozone O3 which protects us from the harmful ultraviolet radiation wavelength 255 nanometer coming from the sun. These radiations cause skin cancer, melanoma in humans. Therefore, it is important to maintain the ozone shield. Ozone in the stratosphere is a product of ultraviolet radiation acting on dioxygen molecules. The UV radiations split split apart molecular oxygen into free oxygen atoms. These oxygen atoms combine with the molecular oxygen to form ozone as given below in the reaction. O2 molecule, because of the UV light, breaks into two oxygen atoms. Oxygen atoms therefore combines with the oxygen molecule under the presence of sunlight gives ozone gas. Ozone is thermodynamically unstable and decomposes to molecular oxygen. Thus, a dynamic equilibrium exists between the production and decomposition of ozone molecules. In recent years, there have been reports of the depletion of this protective ozone layer because of the presence of certain chemicals in the stratosphere. The main reason of ozone layer depletion is believed to be the release of chlorofluorocarbon compounds, CFCs, also known as freons. These compounds are non-reactive, non-flammable, non-toxic organic molecules and therefore used in refrigerators, air conditioners, in the production of plastic foam, and by the electronic industry for cleaning computer parts. Once CFCs are released in the atmosphere, they mix with the normal atmospheric gases and eventually reach the stratosphere. In the stratosphere, they get broken down by powerful UV radiations, releasing chlorine-free radicals CF2, Cl2 under the presence of UV light, free radicals of chlorine and free radicals CF2Cl. The chlorine radical then react with stratospheric ozone to form chlorine monoxide radicals and molecular oxygen. Reactions of chlorine monoxide radicals with atomic oxygen produces more chlorine radicals. The chlorine radicals are continuously regenerated and cause the breakdown of ozone. Thus, CFCs are transporting agents for continuously generating chlorine radicals into the stratospheric part of the atmosphere and damage the ozone layer. The ozone hole. In 1980s, atmospheric scientists working in Antarctica reported about depletion of ozone layer, commonly known as ozone hole over the South Pole. It was found that a unique set of conditions was responsible for the ozone hole. In summer season, nitrogen dioxide and methane react with chlorine monoxide reaction 4 above and chlorine atoms reaction 5 above, forming chlorine sinks preventing much ozone depletion. Whereas in winter, a special type of clouds called polar stratospheric clouds are formed over Antarctica. These polar stratospheric clouds provide surface on which chlorine nitrate formed given in reaction 4 gets hydrolyzed to form hypochlorous acid given in reaction 6. It also reacts with the hydrogen chloride produced as per reaction 5 to give molecular chlorine. When sunlight returns to the Antarctica in the spring, the sun's warmth breaks up the clouds and HOCl and Cl2 are photolyzed by the sunlight, as given in reactions below 8 and 9. The chlorine radicals thus formed initiate the chain reaction for ozone depletion as described earlier. Effects of depletion of the ozone layer. With the depletion of ozone layer, more UV radiation filters into troposphere. UV radiations led to aging of skin, cataract, sunburn, skin cancer, killing of many phytoplanktons, damage to fish productivity, etc. It has also been reported that plant proteins get easily affected by UV radiation, which leads to the harmful mutation of cells. It also increases evaporation of surface water through the stomata of the leaves and decreases the moisture content of the soil. Increase in UV radiation damage plants and fibers causing them to fade faster. 14.3 Water pollution. Water is essential for life. Without water, there would be no life. We usually take water as granted for its purity, but we must ensure the quality of water. Pollution of water originates from human activities through different paths. Pollution reaches surface or groundwater. Easily identified sources or place of pollution is called as point source. For example, municipal and industrial discharge pipes where pollutants enter the water source. Non-point sources of pollution are those where a source of pollution cannot be easily identified. For example, agricultural runoff, such as from farm, animals, and croplands. acid rain, stormwater drainage, such as from streets, parking lots and lawns, etc. Table 14.1 lists the major water pollutants and their sources. 14.3.1 Causes of water pollution. 1. Pathogens. The most serious water pollutants are the disease causing agents called pathogens. Pathogens include bacteria and other organisms that enter water from domestic sewage and animal excreta. Human excreta contain bacteria such as Escherichia coli, Streptococcus faecalis, which cause gastrointestinal disease. A. Organic waste. The other major water pollutant is organic matter such as leaves, grass, trash, etc. They pollute water as a consequence of runoff. Excessive phytoplankton growth within water is also a cause of water pollution. These wastes are biodegradable. The large population of bacteria decomposes organic matter present in water. They consume oxygen dissolved in water. The amount of oxygen that water can hold in the solution is limited. In cold water, dissolved oxygen (DO) can reach a concentration up to 10 ppm, that is parts per million, whereas oxygen in the air is about 2 lakh parts per million. That is why even a moderate amount of organic matter, when decomposes in water, can deplete the water of its dissolved oxygen. The concentration of dissolved oxygen in water is very important for aquatic life. If the concentration of dissolved oxygen of water is below 6 ppm, the growth of fish gets inhibited. Oxygen reaches water either through atmosphere or from the process of photosynthesis carried out by many aquatic green plants during daylight. However, during night, photosynthesis stops, but the plants continue to respire, resulting in reduction of dissolved oxygen. The dissolved oxygen is also used by microorganisms to oxidize organic matter. If too much of organic matter is added to the water, all the available oxygen is used up. This causes oxygen dependent aquatic life to die. Thus, anaerobic bacteria, which do not require oxygen, begin to break down the organic waste and produce chemicals that have a foul smell and are harmful to human health. Aerobic oxygen requiring bacteria degrade these organic wastes and keep the water depleted in dissolved oxygen. Thus, the amount of oxygen required by bacteria to break down the organic matter present in a certain volume of sample of water is called BOD, biochemical oxygen demand. The amount of BOD in the water is a measure of the amount of organic material in the water in terms of how much oxygen will be required to break it down biologically. Clean water would have BOD value of less than 5 ppm, whereas highly polluted water could have a BOD value of 17 ppm or more. 3. Chemical pollutants. As we know that water is an excellent solvent, water soluble inorganic chemicals that include heavy metals such as cadmium, mercury, nickel, etc. constitute an important class of pollutants. All these metals are dangerous to humans because our body cannot excrete them. Over the time it crosses the tolerance limit. These metals then can damage the kidneys, central nervous system, liver, etc. Acids like sulfuric acid from mine drainage and salt from many different sources, including raw salts used to melt snow and ice in the colder climates, are water soluble chemical pollutants. The organic chemicals are another group of substances that are found in polluted water. Petroleum products pollute many sources of water. For example, major oil spills in oceans. Other organic substances with serious impacts are the pesticides that drift down from sprays or runoff from lands. Various industrial chemicals like polychlorinated biphenyls (PCBs), which are used as cleansing solvent, detergents, and fertilizers add to the list of water pollutants. PCBs are suspected to be carcinogenic. Nowadays, most of the detergents available are biodegradable. However, their use can create other problems. The bacteria responsible for degrading biodegradable detergent feed on it and grow rapidly. While growing, they may use up all the oxygen dissolved in water. The lack of oxygen kills all other forms of aquatic life, such as fish and plants. Fertilizers contain phosphates as additives. The addition of phosphates in water enhances algae growth. Such profuse growth of algae covers the water surface and reduces the oxygen concentration in water. This leads to the anaerobic conditions, commonly with accumulation of obnoxious decay and animal death. Thus, bloom-infested water inhibits the growth of other living organisms in water body. This process, in which nutrient-enriched water bodies support a dense plant population, which kills animal life by depriving it of oxygen and results in subsequent loss of biodiversity, is known as eutrophication. 14.3.2 International Standards for Drinking Water. The international standards for drinking water are given below and they must be followed. Fluoride. For drinking purposes, water should be tested for fluoride ion concentration. Its deficiency in drinking water is harmful to man, causes diseases such as tooth decay, etc. Soluble fluoride is often added to drinking water to bring its concentration up to 1 ppm or 1 milligram per decimeter cube. The fluoride ion makes the enamel on teeth much harder by converting hydroxyapatite, the enamel on the surface of the teeth, into much harder fluorapatite. However, fluoride ion concentration above 2 ppm causes brown mottling of teeth. At the same time, excess fluoride over 10 ppm causes harmful effect to bones and teeth, as reported from some parts of Rajasthan. Lead. Drinking water gets contaminated with lead. When lead pipes are used for transportation of water, the prescribed upper limit concentration of lead in drinking water is about 50 ppb parts per billion. Lead can damage kidney, liver, reproductive system, etc. Sulfate. Excess sulfate more than 500 ppm in drinking water causes laxative effect. Otherwise, at moderate levels, it is harmless. Nitrate. The maximum limit of nitrate in drinking water is 50 ppm. The excess nitrate in drinking water can cause disease such as methemoglobinemia. Other metals. The maximum concentration of some common metals recommended in drinking water are given in table 14.2. Maximum concentration for iron is 0.2, for manganese is 0.05, for aluminum is 0.2, for copper it is 3, zinc it is 5, and for cadmium it is 0.005 milligram per decimeter cube. Soil pollution. India, being an agriculture-based economy, gives high priority to agriculture, fisheries, and livestock development. The surplus production is stored by governmental and non-governmental organizations for the lean season. The food loss during the storage also needs special attention. Have you ever seen the damages it caused to the crops, food items by the insects, rodents, weeds and crop diseases, etc.? How can we protect them? You are acquainted with some insecticides and pesticides for protection of our crops. However, these insecticides, pesticides, and herbicides cause soil pollution. Hence, there is a need for their judicious use. 14.4.1 Pesticides. Prior to the World War II, many naturally occurring chemicals such as nicotine by planting tobacco plants in the crop field were used as pest controlling substance for major crops in agricultural practices. During World War II, DDT was found to be of great use in the control of malaria and other insect-borne diseases. Therefore, after the war, DDT was put to use in agriculture to control the damages caused by insects, rodents, weeds, and various crop diseases. However, due to the adverse effects, its use has been banned in India. Pesticides are basically synthetic toxic chemicals with ecological repercussions. Thus, the repeated use of the same or similar pesticide gives rise to pests that are resistant to that group of pesticides, thus making the pesticides ineffective. Therefore, as insect resistance of DDT increased, other organic toxins such as eldrin, dieldrin were introduced in the market by pesticide industry. Most of the organic toxins are water insoluble and non-biodegradable. These high persistent toxins are therefore transferred from lower trophic level to higher trophic level through food chain. Figure 14.3. Over the time, the concentration of toxins in higher animals such reach a level which causes serious metabolic and physiological disorders. In response to high persistence of chlorinated organic toxins, a new series of less persistent or more biodegradable products called organophosphates and carbamates have been introduced in the market, but these chemicals are severe nerve toxins and hence more harmful to humans. As a result, there are reported of some pesticides related deaths of agricultural field workers. Insects have become resistant to these insecticides also. The insecticide industry is engaged in developing new group of insecticides, but one has to think, is this the only solution to pest menace? These days, the pesticide industry has shifted its attention to herbicides such as sodium chlorate, sodium arsenite, and many others. During the first half of the last century, the shift from mechanical to chemical weed control had provided the industry with flourishing economic market. But one must remember that these are also not environment friendly. Most herbicides are toxic to mammals but are not as persistent as organochlorides. These chemicals decompose in a few months. Like organochlorides, these too become concentrated in the food web. Some herbicides cause birth defects. Studies show that car- cornfields sprayed with herbicides are more prone to insect attack and plant disease than fields that are weeded manually. Pesticides and herbicides represent only a very small portion of widespread chemical pollution. A large number of other compounds that are used regularly in chemical and industrial processes for manufacturing activities are finally released in the atmosphere in one or other form. 14.5 Industrial wastes. Industrial solid wastes are also sorted out as biodegradable and non-biodegradable wastes. Biodegradable wastes are generated by cotton mills, food processing units, paper mills, and textile factories. Non-biodegradable wastes are generated by thermal power plants, which produce fly ash, integrated iron and steel plants, which produce blast furnace slag and steel melting slag. Industries manufacturing aluminum, zinc, and copper produce mud and tailings. Fertilizer industries produce gypsum. Hazardous wastes such as inflammables, composite explosives, or highly reactive substances are produced by industries dealing in metals, chemicals, drugs, pharmaceuticals, dyes, pesticides, rubber goods, etc. The disposal of non-degradable industrial solid waste, if not done by a proper and suitable method, may cause serious threat to the environment. New innovations have led to different uses of waste material. Nowadays, fly ash and slag from the steel industry are utilized by the cement industry. Large quantities of toxic wastes are usually destroyed by controlled incineration, whereas small quantities are burnt along with the factory garbage in open bins. Moreover, solid waste, if not managed effectively, affect the components of the environment. Do you know about waste recycling? Fuel obtained from plastic waste has high octane rating. It contains no lead and is known as green fuel. Due to recent developments made in chemical and textile industries, clothes will be made from recycled plastic waste. These will be available soon in the global textile market. In India, our cities and towns face endless hours of power cut. We can also see piles of rotting garbage here and there. There is a good news that we can get right from both these problems simultaneously. Technology has now been developed to produce electricity from the garbage. A pilot plant has been set up where, after removing ferrous metals, plastic, glass, paper, etc., from garbage, it is mixed with water. It is then cultured with bacterial species for producing methane, commonly known as biogas. The remaining product is used as manure and biogas is used to produce electricity. 14.6 Strategies to control environmental pollution. After studying air, water, soil, and industrial waste pollution in this unit, by now you must have started feeling the need of controlling environmental pollution. How can you save your immediate environment? Think of the steps or activities which you would like to undertake for controlling air, water, soil, and industrial waste pollution in your neighborhood. Here, an idea about the strategies for the management of waste is given. 14.6.1 Waste Management. Solid waste is not the only waste which you see in your household garbage box. Besides household discards, there are medical, agricultural, industrial, and mining wastes. Also, The improper disposal of waste is one of the major causes of environmental degradation. Therefore, the management of waste is of the utmost importance. You must be aware of the Swachh Bharat Abhiyan or Clean India mission launched by the Government of India. Two programs are being implemented under the broad umbrella of the Swachh Bharat Abhiyan. These are Swachh Bharat Mission Urban, Swachh Bharat Mission Gramin. The Swachh Bharat Mission Urban primarily aims at making urban India free from open defecation and achieving 100% scientific management of solid waste in the country. The Swachh Bharat Mission Gramin targets to bring about an improvement in the general quality of life in rural areas by promoting cleanliness and hygiene and eliminating open defecation. It is accelerating its efforts to achieve the goal of universal sanitation coverage by 2nd October 2019, which is the birth anniversary of the Mahatma Gandhi. If you have participated in some event on Swachh Bharat Mission, write your experiences. Collection and disposal. Domestic wastes are collected in small bins which are then transferred to community bins by private or municipal workers. From these community bins, these are collected and carried to the disposable site. At the site, garbage is sorted out and separated into biodegradable and non-biodegradable materials. Non-biodegradable materials such as plastic, glass, metal scraps, etc. are sent for recycling. Biodegradable wastes are deposited in landfills and are converted into compost. The waste, if not collected in garbage bins, finds its way into the sewers. Some of it is eaten by cattle. Non-biodegradable wastes like polythene bag, metal scraps, etc. soak the sewers and cause inconvenience. Polythene bags, if swallowed by animals, can cost their lives also. As a normal practice, therefore, all domestic waste should be properly collected and disposed. The poor management causes health problems leading to epidemics due to contamination of groundwater. It is especially hazardous for those who are in direct contact with the waste, such as rag pickers and workers involved in waste disposal, as they are the ones who handle waste materials mostly without protective device such as gloves or waterproof boots and gas masks. What can you do for them? 14.7 Green Chemistry. 14.7.1 Introduction. It is well known fact that self-sufficiency in food has been achieved in India since late 20th century by using fertilizers and pesticides and exploring improved methods of farming, good quality seeds, in irrigation, etc. But over exploitation of soil and excessive use of fertilizers and pesticides have resulted in the deterioration of soil, water, and air. The solution of this problem does not lie in stopping the process of development that has been set up in, but to discover methods which would help in the reduction of deterioration of the environment. Green chemistry is a way of thinking and is about utilizing the existing knowledge and principles of chemistry and other sciences to reduce the adverse impact on environment. Green chemistry is a production process that would bring about minimum pollution or deterioration to the environment. The byproducts generated during a process, if not used gainfully, add to the environmental pollution. Such processes are not only environmental unfriendly but also cost ineffective. The waste generation and its disposal both are economically unsound. Utilization of existing knowledge base for reducing the chemical hazards along with the development of developmental activities is the foundation of green chemistry. Have you perceived the idea of green chemistry? It is well known that organic solvents such as benzene, toluene, carbon tetrachloride, etc. are highly toxic. One should be careful while using them. As you know, a chemical reaction involves reactants attacking reagents and the medium in which the reaction takes place. Extent of any reaction depends upon physical parameters like temperature, pressure, and use of catalyst. In a chemical reaction, if reactants are fully converted into useful environmental friendly products by using an environment friendly medium, then there would be no chemical pollutants introduced in the environment. During a synthesis, care must be taken to choose starting materials that can be converted into end products with yield approximately up to 100%. This can be achieved by arriving at optimum conditions of synthesis. It may be worthwhile to carry out synthetic reactions in aqueous medium. Since water has high specific heat and low volatility, water is cost effective, non inflammable, and devoid of any carcinogenic effects. 14.7.2 Green chemistry in day to day life. 1. Dry cleaning of cloths. Tetrachloroethane was earlier used as solvent for dry cleaning. The compound contaminates the groundwater and is also a suspected carcinogen. The process using this compound is now being replaced by a process where liquefied carbon dioxide with a suitable detergent is used. Replacement of halogenated solvent by liquid carbon dioxide will result in less harm to groundwater. These days, hydrogen peroxide is used for the purpose of bleaching clothes in the process of laundry, which gives better results and makes use of lesser amount of water. Bleaching of paper. Chlorine gas was used earlier for bleaching paper. These days, hydrogen peroxide with suitable catalyst which promotes the bleaching action of hydrogen peroxide is used. 3. Synthesis of chemicals. Ethanol is now commercially prepared by one-step oxidation of ethene in the presence of ionic catalyst in aqueous medium with a yield of 90%. Point 4. Green solution to clean turbid water. Power of kernel of tamarind seeds has been found to be an effective material to make municipal and industrial wastewater clean. It is non-toxic, biodegradable, and cost-effective material. This powder is usually discarded as agricultural waste. The present practice is to use alum to treat such water. It has been found that alum increases toxic ions in treated water and can cause diseases. Green chemistry, in a nutshell, is a cost effective approach which involves reduction in material, energy consumption, and waste generation. Think it over. What is our responsibility as a human being to protect our environment? Some concepts, if followed by an individual, contribute towards a better quality of our environment and human life. Always set up a compost tin in your garden or any other place in your home and use it to produce manure for your plants to reduce the use of fertilizers. Use a cloth bag and avoid asking for plastic carry bags when you buy groceries, vegetables, or any other item. See that All newspapers, glass, aluminum, and other items in your area are recycled. We might have to take little trouble to locate such dealers. We must realize that we do not have solution for every problem, but we can concentrate on issues which we feel strongly about and can do so something about. We should take care of to put into practice whatever we preach. Always remember, environment protection begins with us. Summary: environmental chemistry plays a major role in environment. Chemical species present in the environment are either naturally occurring or generated by human activities. Environmental pollution is the effect of undesirable changes in the surrounding that have harmful effects on plants, animals, and human beings. Pollutants exist in all the three states of matter. We have discussed only those pollutants which are due to human activities and be controlled. Atmospheric pollution is generally studied as tropospheric and stratospheric pollution. The troposphere is the lowest region of the atmosphere in which man, along with other organisms, including plants, exist, whereas stratosphere extends above troposphere up to 50 km above sea level. Ozone layer is one of the important constituents of the stratosphere. The troposphere solution is basically due to various oxides of sulfur, nitrogen, carbon, halogens, and also due to particulate pollutants. The gaseous pollutants come down to Earth in the form of the acid rain. 75% of the solar energy reaching Earth is absorbed by the Earth's surface and rest is radiated back to the atmosphere. These gases mentioned above trap the heat which results into global warming. It is important to realize that these very gases are also responsible for the life on the earth as they trap the requisite amount of solar energy for the sustainable of life. The increase in the greenhouse gases is raising the temperature of the Earth's atmosphere, which, if not checked, may eventually result in melting of polar ice caps and consequently may submerge the coastal and land mass. Many human activities are producing chemicals which are responsible for the depletion of ozone layer in the stratosphere, leading to the formation of ozone hole. Through the ozone hole, ultraviolet radiations can penetrate into the Earth's atmosphere, causing mutation of genes. Water is the elixir of life, but the same water, if polluted by pathogens, organic wastes, toxic heavy metals, pesticides, etc., will turn into poison. Therefore, one should take care to follow international standards to maintain purity levels of drinking water. Industrial wastes and excessive use of pesticides result into pollution of land mass and water bodies. Judicious use of chemicals required for agricultural practices can lead to sustainable development. Strategies for controlling environmental pollution can be: first, waste management, that is, reduction of the waste and proper disposal, also recycling of materials and energy. Second, adopting methods in day to day life which results in the reduction of environmental pollution. The second method is a new branch of chemistry which is in its infancy, known as green chemistry. It utilizes the existing knowledge and practices so as to bring about reduction in the production of pollutants.